Welcome to our daily MCQ series, day 3, where we'll be seeing forming questions. Cold working of steel is defined as working at its crystalline temperature, above its recrystalline temperature, below its recrystallization temperature, at two-thirds of the melting temperature of metal. So, when we are doing the hot working, we need to restructure the grain. So we have to work above the recrystalline temperature. For the cold working, it should be below the recrystallization temperature. Okay. So the correct answer will be C. So our next question is, a metal disc of 20 mm diameter is to be punched from a sheet of 2 mm thickness. The punch and die clearance is 3%. The required punch diameter is 19.8 mm, 19.94 mm, 20.06 mm, 20.12 mm. So here the important part is the difference between punching and blanking operation. So what is the useful part and what is not useful. So take the reference of the punch that you directly do in the papers of pinup. So here we are doing the punching operation. So our paper is important and the punching we are doing will be scrapped. So the clearance should be given in the punch and not in the sheet. Sheet hole should be of a required diameter. So our important part is the sheet and the clearance will be given in the punch. So the punch diameter will be subtracted by the variation. So our required diameter is 20 mm and this will be subtracted, the clearance will be subtracted from the punch. So that will be 2 into clearance of 3% into thickness of 2 mm. So that will give 19.88 mm. So this should be the punch and the hole that will be made finally will be of 20 mm. So our correct answer will be A. Next question. In a rolling process, the sheet of 25 mm thickness is rolled to 20 mm thickness. Rolling is of diameter. Roll is of diameter 600 mm and it rotates at 100 rpm. The roll strip contact length will be 5 mm, 39 mm, 78 mm, 120 mm. So first we have to see what is the rolling process. Here two rolls like this and one will be here also. So two rolls are used for this uh, lowering the thickness of this material. So initial thickness was 25 mm, the final thickness is coming out to be 20 mm. So this process is called rolling. Now we have two rolls of 600 mm and it is asking about the strip contact length. What will be the strip contact length? This will be the strip contact length. This is given by under root of r into draft, the reduction. So r value here is 300, diameter half of the diameter, so that is 300, initial thickness 25, final thickness 20 will give you 38.70. So the correct answer will be 39. So our next question is match the following items. The first column is the products: molded luggage, packaging containers for liquid, long structural shapes, collapsible tubes, and the process. Which process is used? Injection molding, hot rolling, impact extrusion, transfer molding, blow molding, twining. So first we have to see what these processes are. First is the injection molding. So here a powdered material is kept in the hopper type system and it is fed to the system, and this plunger will use it to push it to the final object. This type injection type system, so that is why it is called injection molding. Next is the hot rolling. As we have seen earlier, the numerical part also, this is used for putting this onto the hot rolling plate and the thickness is reduced. Third is the impact extrusion. So because of this impact, the material here tries to move up from both the sides corners. So this is called the impact extrusion. Next is the transfer molding. Here the material kept in the chamber is pushed down to the separate chamber, that is actually the cavity. So this type of transfer happens, that's why it's called transfer molding. Next is the blow molding, where a jet is used for blowing up the air, and that causes the sheets, the side sheets, to take up the shape of the die. Okay, so this is blow molding. Coining is actually the process where we need to engrave something, like our original coin also. One side we have the Ashok Chakra, one side we have the numerical values of the coin. So that requires engraving on both the sides. So this type of pressing is done, and this gives a surface that is having the features of this die. So these are the 5 processes. Now what process we have to use here? So the correct answer here is B. B means P to 4. This will be used for transfer molding. The fourth one is transfer molding. So we are taking the luggage out of this. Next is the package material for liquid. So this is the fifth one. So the toothpaste tubes are used as prepared by this method, because we need a hollow structure in between. Next is long structural shapes. So that is based by the hot rolling, because it is directly made through this, as you have seen earlier also. And last part is the collapsible tubes, that is the impact fusion. These this is a tube type 3D figure, so it will make this type of tube. So the collapsible tubes are made using impact extrusion. The correct answer is B. Next question. A 4 mm thick sheet is rolled with 300 mm diameter rows to reduce the thickness without any change in its width. The friction coefficient at the work roll surface interface is 0.1. The minimum possible thickness of the sheet that can be produced in a single pass is. So here we have to see that there is a limit of how much reduction is possible. So that only, and that is a function of coefficient of friction. So only that much of material will be able to be reduced. We cannot reduce directly from, like, say 4 mm to 1 mm. So that there is a limit that only this much reduction is possible. So that part is discussed here. And if we have to reduce it further, then we have to use multiple passes. So first roll will be here, okay, this type. Second roll will be here. So this type of rolls are multiple passes, and this reduction is achieved here. Final reduction. So this is what it is asking. So what is the minimum possible thickness that can be achieved in a single pass, taking the coefficient of friction as 0.1. So the maximum thickness is function of, again, this formula we have seen earlier also, mu. So this reduction is dependent on this mu. Okay. So Ti is the initial thickness, Tf the final thickness, R is the roller radius. So we'll put the values. Mu is the coefficient of friction, Ti is 4, Tf on 150 is the radius, that gives us 2.5 mm. So we can reduce 4 mm thickness to only 2.5 mm. And if you want to do this again, or we need a lesser thickness, then we have to do this process again. So that is the type of operation this is. So our correct answer will be 2.5. Next question. In a deep drawing, in a wire drawing operation, diameter of the steel wire is reduced from 10 mm to 8 mm. The mean flow stress of the material is 400 megapascal. The ideal force required for drawing, ignoring friction and redundant work, is 4.48 kilonewton, 8.97, 20.11, 31.4. So here you can see the best type of solution is to directly see the values. We need force, we have stress. So we just need to multiply with area. So what will be the area here? Area will be the area of the final wire. So that will give the wire drawing operation force. So the final area is here made by this 8 mm. Okay. So 5/4 d square This is the area, circular cross section into the stress, and that will give the force. Use this formula for all the force required. This will give the force directly, stress into area. So our correct answer here will be 20.11. Okay, so our next question is match the following items. So in the first column we have the defects, wrinkling, orange peel, stretcher strains, errings, and in the second column we have the causes, yield point elongation, anisotropy, large grain size, insufficient blank holding force, fine grain size, excessive blank holding force. So first we have to see what these defects are actually. First is the wrinkling defect. Wrinkling defect, here you can see when this punch was pushed into this and this type of shape was made, but the holding force was not strong enough. So the wrinkles were formed at the end. Okay. Now the orange peel, when the size of the grain is very large, so in that case we'll see this type of orange peel type skin because of the grain size. Next is the stretcher strains. Stretcher strains, as you can see minutely here, the lines that are formed here, these are called the stretcher strains. This is generally because of the expansion beyond the yielding. So here we will see the, yeah, this one, yield point elongation. This will give you the stretcher mark. And next is the earrings. Earrings are the non-uniformity at the surfaces. This is because of the anisotropy of the material. Some of the material is thick at some point and some are not so thick. So this type of, so the correct answer will be 4. Next question, in a open die forging, a disc of diameter 200 mm and height 60 mm is compressed without any barreling effect. The final diameter of the disc is 400 mm. The true strain is 1.9, 1.6, 1.3, 0.6. So here what we are doing, we are trying to find the strain in the process of die forging. When we are beating it, what will be the strain? So strain formula is, as we all know, it is final area divided by the initial area. We are taking the log because of the circular part. So the strain will give you, and in this case we have the diameter only, not the area. So we will be using here, we will convert this into diameter. So this will be pi by 4 d square. Again here also pi by 4, and pi by 4 part will be cancelled out. We have d square, and that is taken out here. So we have this formula that is actually derived from the true strain only. So here we'll be putting the final diameter, initial diameter, and that will give you the direct strain. So the correct answer will be C. Next, the thickness of the metallic sheet is reduced from an initial value of 16 mm to final value of 10 mm in a one single pass rolling with a pair of cylindrical rollers, each of diameter 400 mm. The bite angle is in degree will be, so the bite angle is, you can relate it with the frictional force. Like in the friction force also we have the contact angle or friction angle. So that is tan theta, and that is of the mu equals to tan theta. So here the bite angle is also of the same form. So here the bite angle is determined. The formula is same as we have seen earlier for the mu, and here you are taking the tan theta of it to get the angle of friction. So here in this case the bite angle. So the initial thickness is 16 mm, final thickness is 10 mm divided by the radius 200 mm, and this will give you the bite angle of, we have to take the tan inverse of this function. So we'll get the bite angle theta as 9.8. So we can have the D as the correct answer. Last one is the processes again, the blanking, stretch forming, coining, deep drawing, and the types of loading or stresses that is developed while these processes are conducted. So tension, compression, shear, tension, compression, tension, shear. So here the first we have to see what are these processes. First is the blanking. Yeah. So this one I was saying, like in the punching operation, when we punch in the piece or paper, we are using the punch part as the scrap, and we are using the sheet. So this is called a punching operation. And when we are taking the cutout piece as the final product, or we are using this as the final product, so this operation is called blanking. So this is a very important question that is also in the interview also, what is the difference between punching and blanking. So the process is same, it's just because of the product, final product that we are using will will differentiate between the punching and blanking operation. Next is the stress forming. So this type of gripping jaws are used for like holding the metal piece. And this is a sheet of metal, not a wire. This is a sheet. That sheet is taking the shape of this die because of this forces. Next is the coining. Coining you have already seen, like pressing on both the sides of the coin, and that will engrave on both the sides Ashok Chakra and next is the deep drawing, where this die is pressed onto this sheet, and the sheets take the shape as along the clearance between this. So this clearance part is filled with this material, and this is called deep drawing. These are generally used in the utensils, the kitchen utensils that we use, like the katori and bhagona. These are made generally by this process, deep drawing. So what are the stresses here? First one is blanking. So blanking requires shear because this is the cutting part. Next is the tension. As you can see, the sheet is stressed onto this, so that will cause tension. Coining will be compression because, as you can see, we are compressing it from both the sides. And the last one is the deep drawing. This drawing is actually compression onto this part, the center part, and tension on this side part. Like these sides will be under tension and this will be under compression. So we have both the types of stresses into this. So okay, so this will be completing our today's lecture. Thank you for listening. You have been an amazing audience. See you soon with the next video.